I have the fantastic honor of being able to introduce our next speaker, and we will just jump right in there to kind of stay on schedule. We're doing really well. So the next speaker is going to present a different topic, but interestingly, I thought that Mandy's comment about having seen changes in the industry over the last 30 years might be something that's right up the alley of our next speaker. So Duo Qin is currently Professor of Economics at SOAS University in London. She received her PhD from the University of Oxford in 1990, and her research interest branched broadly in two directions. One, the history of econometrics, and two, in applied econometric modeling. So she's been leading the way in bringing econometrics into the modern world and into using data science. So I think between Duo and Mandy and Anat, we see that there is endless career opportunities for those of us in the data science field. Duo, I will hand it over to you now. Thank you so much for being with us. You need to unmute your microphone.
Yeah, thank you, Lee, very much for inviting me. And I'm excited to give this talk. And I also feel very much insecure. Sorry, because my eyesight, sorry, I've got a bigger screen. So it's as if I'm looking sideways, but I'm looking at my bigger screen rather than my laptop, which is too small for me. Anyway, I feel great pleasure to be, it's a great honor to be invited for this talk. And I also feel the pleasure and the insecurity in me because I feel myself very much ignorant of machine learning and statistical learning. And I told you kind of when you first invite me that my knowledge in machine learning and statistical learning is very, very much limited to online lectures, say more or less from Stanford University, and the textbook reading by myself, because for the last 4 or 5 years, I've been very much intrigued by machine learning. And therefore, I started this journey very late, and my knowledge of machine learning is so limited. However, I think there's a similarity with the previous speaker that I have over 30 years of experience in economics and in the academic world and out of the academic world. So I can see the problems in my profession, especially after being exposed myself to machine learning. I feel desperate that we need help, we need new blood, and we need, first of all, new textbooks, totally different textbooks in teaching the next generation how to do economic modeling. So that's basically what I'm trying to say for this talk.
Excellent. I think you're right on target. And I think that machine learning and data science has so much to learn from econometrics and behavioral science, and they're all very closely tied together. So well done.
Sure. Yes, I do know. But I feel that now, because machine learning is such an exciting topic and show a lot of practical kind of advantages and opportunities. So we are more or less being left behind. Nobody seems to care. And also, on the other hand, when I talk to statistics learning, machine learning people, they say, oh, your textbook's so advanced, we can't understand the mathematics in your textbook. You must know a lot more. And it's very sad to be left out with so much advanced theories, but so little success in reality. So that's what we need to change, I think.
Okay. So I'll let you have it. Thank you.
I think my PP, yeah, okay. I just need to wait.
Sorry about this.
Yeah.
Thought it was done.
Yes, please, yes. Okay. Right, thank you. Right. My talk would be quite slightly different from the previous ones because as from Lee's introduction, that I got my PhD doing the research in history of econometrics, whereas it's such a tiny subject, and it's a shame very few people is in this discipline. So I can't survive in the academic world by doing history research. So I end up being an applied economist. And therefore, my talk might not be so forward-looking. I'll tell you something about history, and for good reason. I hope that, and also I realize that the majority of the audience might not be economists or trained as economists, so I need to try to adapt my talk to those who are planning to do economics or who have done economics, and to tell you what the textbook econometrics is, and then show you what the problem is. So I should be able to click, yeah, okay. So the main theme, I thought I start from this famous paper by this statistician, he's passed away sadly already, of the statistical modeling of the two cultures. Basically, the two cultures he described is what he called the data modeling culture versus the algorithm modeling culture, which now we all interpret as the classical statistics versus machine learning. And for those of you who are experts in machine learning, know this paper is very old, about 2 decades ago. But sadly, that within our discipline, among economists and econometricians, the culture of classical statistics still dominate to such an extent that there's a collective negligence, or we are just totally unaware of the machine learning culture. Even though in our research areas, there are a lot of statistical learning efforts during the past 100 years, but that effort has never been able to penetrate into the textbook econometrics and into our economic teaching. And I'm trying to elaborate this main theme by telling you a little bit about the history of econometrics, which is my kind of expertise probably. But however, by doing that background context, I hope for the whole broad audience of this conference, you will know what the current status of our textbook econometrics is, and then I will more or less tell you what I think we should try to do in order to kind of totally reform the way the textbook econometrics is constructed, so that we can move on with the rest of machine learning community or statistical learning community. So that's the plan of my talk. Now, a bit of history. That econometrics actually came into being, say, when we look back on our history, it's over 100 years old. For the young audience, you might think it's pretty long history, but relatively speaking, within economics, it's very young kind of discipline. It started, we recognize, is from very early kind of data exploratory analysis, say, associated with the efforts trying to forecast commodity prices. And you can well imagine that when you have financial market and trading large quantity of commodities, then you have a lot of time series data, and the early pioneers just want to try to aggregate these data and trying to forecast their movements, their ups and downs. And in those pre-computer age, and the way to explore data, you might not imagine they use transparent paper to plot all the data sets and raise it to the lights and trying to see which series actually most time fluctuate first, and then come up with an index of leading indicators. And the well-known case is called the Harvard Barometer. However, the big impetus of econometrics was the 1929 Great Depression. And a lot of these leading indicators that failed to predict the scale of the Great Depression. And so that led to a surge of data exploratory analysis, say, for example, the National Bureau of Economic Research in the US, trying to come up with measures of business cycles with a focus on the turning points of recession. Okay, so that involves a huge amount of data analysis. And in the meantime, then they're starting building macro models, because the financial market turmoil will trigger a whole recession at the economy-wise, and therefore there is a need to kind of link these data together, the aggregate impact together, so that the government will be able to see what is the ongoing kind of impact of in a section of disturbance going into the macro. So intuitively, it's just like the COVID-19. It started from very micro issue and it can permeate into a whole economy issue, even a global issue. So that's how the macro modeling efforts came into being in the wake of the 1929 Great Recession. So for the young audience, you probably don't know that because of that efforts, the pioneers for those data exploratory research, especially building macro models, that came into being of the Nobel Prize of Economics. And the first laureate is Frisch and Tinbergen. They jointly won the Nobel Prize of Economics because of their contribution to establish econometrics. However, during their time, it's totally a new research area. It's not been kind of become formalized into a discipline in economics. And that effort actually came during the Second World War in the 40s in America. So it's well established that the formalization of econometrics as we know it now came more or less by the two monographs. The first one, the probability approach in econometrics, written by Hovermore, was kind of recognized as the manifesto of econometrics. And then the whole group, there's a whole group of young researchers in what is known the Coase Commission. At the time, the commission was attached to Chicago University, come up with a whole volume entitled Statistical Inference in Dynamic Economic Models, which basically adapt the whole ideas in the Hovermore monograph and put the mathematical rigor to the scheme, which is a full adaptation of classical statistics. And that is more or less the origin or the formal origin of our textbooks. However, since after the World War II in the 50s and 60s, gradually econometrics become introduced into economic discipline and become a separate course of teaching in doing economics degree. And there's a kind of, so both all the textbook is a kind of adaptation of this formalization approach. I'm going to jump a bit of the history towards the basic change of all the reformative elements in the econometric research. What I probably should have said at the end of the previous slides is you probably should see that the formalization of econometrics is basically a formal acceptance of classical statistics being the core of econometrics. And basically, behind this acceptance, meaning that econometrics was set on the conformative ground rather than data exploratory side. So basically, the teaching of econometrics is set on classical statistics and accepting that the job of econometrics is to help with measurement rather than to do data exploratory discovery. And with that note, then there's a kind of a rapid growth of macro modeling assisting government. And one of the most famous one is called the LINK project, led by another laureate, Nobel Prize laureate, Klein. And however, all these global kind of macro modeling collapsed during another crisis, which is the oil crisis of early 1970s. And that none of the macro models or econometric models rightly predicted the turmoil triggered by the oil crisis. So there is a major kind of movement within economics profession, especially among macroeconomists, trying to reform the way that macro modeling is performed. And basically, in this reform efforts, there's a lot of kind of endeavors trying to bring in data exploratory elements into modeling without formally recognize them. So here I'm just going to give you a few lists. It's not exhaustive, but the first well-known one is what in our profession we know, rational expectation, which went hand in hand with what we called vector auto-regression modeling approach. And probably the more current version, and it's kind of arguably that now the current version is moving into what is called a dynamic computable general equilibrium model in that tradition. And basically it was a way trying to represent the macroeconomic data into a system of dynamic equations, and now allowing some nonlinear features in this dynamic system. And then there's another kind of approach similar to that, but with some difference, which we call the LSE, dynamic modeling specification approach. Here, the LSE stands for London School of Economics, because that's historically where this approach emerged. And I will talk a little bit more about this later on, but there's a lot of similarities between the two. However, I think the rational expectation part of the reform very much dominate the LSE approach. And for one reason now I can see, because the LSE approach is too much closer to statistical learning, which is not formally allowed in econometrics. And the other one is business cycle study, which is even more interesting because, as I kind of shortly mentioned about the National Bureau of Economic Research trying to measure business cycle and collect a lot of data. So that effort involves not only understand the dynamics of macroeconomic variables, but also the aggregative effects from sector, from micro into macro elements. So it's a far more challenging aspect of not only trying to understand the dynamics of macro variables, but also trying to see how micro sectors might accumulate some disturbs, so which will amplify into a macro impact. And this part of research is very much driven by data exploratory desire, but very much done in a formative way. So the result of it is a lot more complicated stochastic process, mathematics to come to nonlinear stochastic process, and so on. However, sorry, I shouldn't have clicked. I moved too fast for my slides than what I kind of prepared myself. All those reformative efforts occurred, as I mentioned, after 1970, early 70 kind of oil shock, and during the 80s and 90s. The biggest blow, again, is 2008, the US-led crisis. Have we succeeded forecasting that crisis? No. None of the macro models, as far as I know, have have survived the US crisis. So this is a huge blow. So after nearly over 80 years of research in econometrics, we have very limited results in spite of a lot of adaptation, a huge amount of research in econometrics, a huge amount of complicated modeling. We still haven't achieved it. Here, over the last decade, there is a lot of kind of people rethinking about the failure, and the people argue that it's just totally impossible to build models which can forecast this kind of open world kind of new shocks. and we should humble ourselves and not aiming at forecasting anything, but trying to explain things. So the answer to why the failure is too big a topic, what I want to say here is to point out a major reason which might have contributed, which I think contribute quite a lot to our present failure, which is that for the whole training of econometrics, and which that later on bring into economists, it's all based on this conformative classical statistic training. So we have no room to data exploratory kind of research. So our models that we use are just simply too are not accurate enough to allow us to do any kind of generalization in that. So that brings me to the foundation of what the textbook methodology is. So in spite of all the research, as I mentioned earlier, our textbook methodology is solidly based on classical statistics. So what is our methodology? The next two slides shows. So basically, we all assume, for those of you who have learned the econometrics should agree with me that we all assume when you do econometric textbooks, we assume we know the model. So where do the model come from? They are from they are analytically solvable model from some kind of maximize or minimize conditions, maximize profit, maximize utility, or minimize cost. So the reason of maximization is based on economic incentives. And then, therefore, the model is given, and this model is parametrically given. So our job as an applied economist or econometrician is just trying to measure those given parameters in what we call the structural model, assuming that model holds as true beyond the data, generally true. So I've explained, because we assume if you have algebraically solvable model based on economic incentives, the model must be globally true. So all we need is to provide statistically optimal or consistent estimators to measure those structural parameters given data. However, it's not very surprisingly that because we collect data from an open world, or even if we do experiments, that people or agents behave in an open world, and therefore these measurements will encounter a lot of problems, which is described as data complications. Okay, so even if our aim is very narrow, trying to find statistically significant parameters which are deemed to have economic meaning or interpretable, then this effort tends to fail a lot of the times because of data complication, which is described in our textbooks. And so the only handle us econometricians have to deal with these complications is to revise the estimators. So for those of you who are not economists, probably would be very surprised to know that OLLS, which means ordinary least squares, is notorious in our textbooks. It's been deemed to be a very unusable principle for estimation because it cannot handle those data complications. So the degree of complexity in econometrics textbooks is mainly around more elaborate estimators rather than use the least square principle. So the next page, I'm trying to shift my language. So my previous slides is the way that I describe econometrics for economist students. Whereas here, I'm trying to adapt some of the diagrams which I kind of taught myself from the non-economic circle. And first of all, I find this diagram that I adapted from this paper. It's very much to the core to show the limitation of classical statistics, because you have to start with an idealized problem, idealized data model, and then provide a very consistent solution to that problem, whereas the link of this idealized problem to the real problem tend to be a bit tricky. And a lot of times you need very, very strong control, the experiments, in order to satisfy the background of this idealized problem. And then, because of this framework, then the application tends to fail, because it's very difficult to have this idealized controlled environment. And then linked to the kind of online machine learning courses, you can see the most naive assumption we have is that we do, in economics, as I said, we have all these models, and the models very much resemble what is called supervised learning. We call these models structural models. So we have the target variables, and the only difference is that our structured model has to be algebraically derived based on some optimization principle based on economic incentive. So we assume they are globally correct, which to the machine learning community think it's too naive. But nevertheless, on top of that, we add to the probability assumptions to these models. We assume all the variables involved are actually following some stochastic process. They can be described by probabilities. And therefore, that leads to the only job of econometricians or the textbook econometrics is targeted at how to provide these consistent estimates for the beta, which is the parameter in this given model. And therefore, you can see that it's very narrowly based on classical statistics, and this assumption that there is no model bias beyond the sample, and therefore, the only handle that econometricians have to treat the bias in reality is modify the estimator. And therefore, you can see that the fundamental problem of textbook econometrics is a formal denial of any statistical learning. And that, as I see, is the fundamental problem in our discipline. So the next thing is, how can we change this situation? What I'm trying to see, I want to emphasize is here that actually over the last decades, or even over the last, say, 5 years, there are quite a lot of econometric research trying to use machine learning, and machine learning techniques, because it's been so successful, has been a kind of very popular within modelers, in our economic modelers. But so there is a lot of machine learning elements going on in econometrics, but what they do is they try to adapt those fashionable methods into our discipline, say like neural networks is very, very kind of random forest and all that. However, none, as far as I know, has tried to change the profession at the fundamental level or in a fundamental way. So what I'm trying to argue is it's not adapting the new techniques because they are interesting, but to change the fundamental methodologies. So what does that mean? First of all, I think my profession needs to openly recognize that the data consistent model, the model works with data, should be unknown a priori. So any algebraically derived models from theory, the best they can do is to serve us like a possible model class. However, we should formally recognize we need to adapt into our textbook teaching the concept of the pack learning, which is probably approximately correct learning into a model, and to admit this is the major or the core task of econometrics. We need to learn this model rather than think these models are available globally first. So learning this model, meaning actually, I'm arguing we should have a culture shift, because learning this model, we need to adopt the concept of distribution-free supervised learning, and also acknowledge that the models which fit reality shouldn't be constrained by the probability theory. And because if you read machine learning textbook, you all know that probability theory is a bit too narrow for packed learning. The packed learning actually is a whole lot of algorithm learning by the paper that I cite. So the culture for algorithm learning should dominate the data modeling culture. And that means we have to abandon our assumed foundation of probability theory. We should let probability theory or classical statistics becomes assistant to this model learning rather than a dominant, assume the model learning is done by theorists. So we need to allow for the learning, and we need to allow probability theory to become an assistant to this learning process. And especially that we need to discover the model first, and then trying to use probability for diagnostics and for kind of deep learning or feature learning. So basically, we should try to kind of work together with statistic learning people and then realize that we should adopt their culture so that we can add our subjective knowledge to make our model, our statistically learned models, more parametrically interpretable, and then trying to help design better economic model with features which we can interpret using our subjective knowledge. And within this new framework, parametric estimation is incorporated in this learning rather than the top or the primary task of econometrics. So thinking about this whole kind of change of concepts or the way restructure the way we teach econometrics seem to be such huge challenge, which if any of you know the textbook econometrics, none of this is the current state of our textbook in econometrics. So thinking about this, being teaching applied econometrics for over 30 years in my profession, sometimes I'm very pessimistic, but trying to write this note and trying to think about the positive side, then I become more optimistic for the following reason. I think this change will come sooner or later, and we have all the right elements, and there's not much we need to do. So what I'm trying to present as almost my last slide is this kind of very optimistic way to show that this reform is not as challenging as it should be. Why? First of all we need to do for econometricians or people teaching econometrics in our profession is just trying to widen our vision of what should be machine learning and to adopt the fundamental theories from machine learning, just from textbooks, say the concepts of learnability, the theories of generalization, they are all readily available in machine learning textbooks. So we're just trying to widen our kind of vision. Instead of picking up the machine learning techniques we think mathematically interesting to our profession, we need to kind of slightly looking further ahead and looking at what is the concept of learnability, what is the concept of generalization, and just adopt those concepts. So it's not too much for extra efforts. Secondly, we should basically slightly changing our vision because the way econometrics can evolved, it's very much of pioneer in a way that because it's all established before the computing age, so historically that we rely on too much mathematics modeling for model formulation and not enough on data exploratory studies. So all we need is slightly changing this view. Basically, we should change our kind of perception of mathematics is the only justification for a global model. And we should accept that mathematics is not a master, it should be our mate. And then also I'm trying to argue, actually, statistical learning is not new. It's been in the history of econometrics for decades, if not 100 years. So all we need to do is relook at history, say, yes, we do have we do have statistical learning elements long in our research tradition. And all I want to mention here, probably because of my kind of professional habit in history, is 3 examples. First of all, there's a huge debate in the late 40s when, right after econometrics was formalized by Coase Foundation, there's a debate about measurement without theory or measurement without discovery. Basically, those people who formalized econometrics accused the National Bureau of Economic Research economists of doing measurement without theory. And then the other camp saying you are doing measurement without discovery. So the textbook econometrics came into being by aligning with measurement with theory at the cost of going down to the root of measurement without discovery. So the way I've been very critical of econometrics is that we are not taught to have discovery, to allow for data discovery. So that's one of the examples. We need to have measurement with revise the theories to allow for data discovery. And the second example goes even back, kind of more back than this measurement without theory kind of argument, which from very early on, Keynes is one of the famous economists. They were always arguing and questioning that probability measures might be too narrow to kind of to describe the economic uncertainty we're trying to cover for. So a lot of economic uncertainty should be a lot broader than what probability measures can cope with. And that's exactly what machine learning is doing. And finally, I want to mention the LSE approach. If you reread the LSE approach, it's a very modern way of doing basically statistical learning, including all the elements. So my core argument is that this challenge, there's no technical challenge, there's no new elements. All we need to do is to change our view and acknowledge our communal ignorance outside the econometrics. So that leads me to my very last slide. I want to show that so far, if we openly recognize our ignorance, we can go on, and it's a golden age to adopt statistical learning because there have been so much successful story and there's such a mature theory about learnability. Thank you.
Thank you, Duo. That was terrific. I think that maybe we'll have some of the young data scientists with just bachelor's degrees be applying for econometrics, masters and PhDs, which would be a terrific place to see some new data scientists study. Yeah, and bringing the learning into the field. So I think that we're going to take a break until 1 o'clock, and then everyone will be able to log in. I've put in the chat group where to log in for the networking groups.
Okay.
Thank you so much, Duo.
Thank you. So do you want me to take questions after 1 o'clock or something?
Right now we don't have any questions, but I think we've left people with lots to think about.
Sure.
And hopefully to think about the fact that we need to be looking at the data from the Great Depression as well as from the recession of the 70s, and applying some good machine learning to it in order to figure out what to do in the coming years very quickly. Yeah. So that was really terrific. I think there's lots of good projects laying in there.
Thank you.
Thank you.